Hey guys, we're Team 5, including Jonghu, Max, myself Jongin, and GPT, helping out as our coding and domain teammate. In this project, we're predicting Scope 1 and Scope 2 greenhouse gas emissions for companies, and I'm going to be walking through how we approach the problem, starting from our hypothesis, EDA, feature engineering, and finally the models and results. So first, we wanted to ground ourselves in what exactly we're predicting. Scope 1 emissions are the direct operational emissions, things like combustion and industrial processes. Scope 2 emissions are indirect and mostly depend on electricity use and the carbon intensity of the national grid. And because companies often don't disclose their emissions, improving model accuracy actually has real financial impact. Lowering mean absolute errors even by 10,000 tons reduces valuation uncertainty by almost $500,000 under common carbon pricing assumptions. So this isn't just a prediction challenge, but more of there's real downstream value. Once we opened the data set, the first thing we noticed was how extremely skewed both Scope 1 and Scope 2 are. A handful of giant emitters completely dominate the scale. So to stabilize the learning, we applied a log transform to both targets. And that being said, we wanted our model prediction to be robust to the outliers, which also aligns with interest of stakeholders aggregating sectors in portfolio level. That derives our primary objective to be MAE and instead of RMSE because tail outliers would dominate the loss otherwise. After understanding the targets, we started building three main feature groups. First, scale features, proxied by total revenue and sector-wise revenue. Geographic feature, such as country and region. And lastly, behavioral and ESG features. And these are going to be the main categories that we establish a set of hypotheses that we then tested through EDA for future modeling decisions. So first hypothesis is business scale. Basically, revenue is the strongest single driver of emissions. We plotted revenue and emissions, and both were extremely skewed. After taking logs, the distributions looked much cleaner. And when we checked their relationship, the log of revenue had about 0.43 correlation with log of total emissions, which implies business scale proxied by revenue does affect emissions and aligns with the validity of our assumptions. This immediately told us log revenue becomes our baseline feature, and every other idea we test later is always conditioned on company size first. Second hypothesis, sector partition revenues provide additional target-specific predictive power for Scope 1 and Scope 2. For example, take two companies with similar total value, one in manufacturing and the other one in consulting firm. Even if their overall emissions appear similar, the source of those emissions differ dramatically. Manufacturing companies generate more direct, process-driven Scope 1 emissions, while consulting firms are dominated by electricity Scope 2 emissions. And this is exactly why sector partition revenue helps us distinguish well emission are coming from and improves our prediction accuracy. We found two important points here. One, if a company has revenue in the relevant scope, the corresponding emissions correlate strongly, meaning sector partition revenue really does provide additional signal beyond the total revenue. Second, some sectors like educations were judged to influence neither scope. Companies in these neutral sectors consistently had much lower emissions than companies with meaningful scope link revenue. Hypothesis 3 was about geography. Even if two companies have the same scale and sector mix, emissions should differ by country. To test this, we grouped companies into revenue quantiles, basically controlling for size, and then compared countries within each bin. As a standalone feature, country shows limited signal, but based on the definition of the scope 1 and 2 emission, it is still important. Regions, on the other hand, were too sparse. Only West Europe and North America had meaningful counts, so we dropped the region and kept the countries. For behavioral features, we looked at ESG scores and SDGs. We dropped the overall score, which is just a weighted sum of environment, social, governance scores. But the adjusted environmental score actually carries signal once we controlled it over revenue. SDGs though didn't help at all, so tiny sample sizes and the inconsistency effects, so we removed them as well. And after building all these features, we ran incremental experiments on our four main models, which was first, linear regression with the baseline features from organizers. Second, median regression plus baseline. Third, median regression with our own defined features with the log target. Lastly, cat boost with our own defined features as well as log target. The best model we have achieved so far was cat boost. We went from scope 1 MAE from 64K to 50K, and scope 2 MAE from 71K to 52K, which is about 22 to 27% improvement, implies pretty solid improvements considering the business impact we mentioned earlier. As a result, our project develops prediction models to estimate company-level greenhouse gas emissions. Through EDA, we constructed an effective feature set, and our proposed method achieved substantial gains compared to the baseline, representing a meaningful business impact that feature group can bring up some insights on top of our project. Thanks for taking time and watching.